This is video notes for section 1.3 of Algebra 1, solving equations with a variable on both sides. Your learning target that you will be graded upon for 1.3 is I can write and solve equations with a variable on both sides. You should be following along in your student companion. If you are unable or do not have your student companion, you should be writing this on a blank sheet of paper, title your section 1.3, and write your I can statement. Pause and come back. Now that you're back in your student companion, we are actually going to start on page 20 with the do you know how problems, and then we'll come back to some examples. We're starting with problem 5, which is solving an equation, and we have variables on both sides. When we say sides, we mean that when you divide the equation in half at the equal sign, and you have the left side and the right side, there are variables on both sides of that equation. The first thing you need to do is simplify. On both sides, before we ever start to combine like terms with the variables. So what I notice on this problem is I see some parentheses with a 5 in front of it, which means I can distribute and multiply that 5. We're going to do that first. 5 times 2x would be 10x's. 5 times 6 would be 30. And then I would bring down my 8x plus 48. Now I look on both sides of my equation and I see that I have a variable plus a number constant equals a variable plus or minus a number constant. I am now ready to group my like terms together using opposite operations. And we're going to start with the variable first. And I've made a little note for you to take on the left side of your paper. Undo your variables from right to left, which means I'm going to look at my variable on the right, which is the 8x, and I want to undo that variable. The opposite of positive 8x is negative 8x. So I'm going to do that to both sides with my like terms. Notice I didn't write it underneath the 30. I did put it underneath the 10x because they both shared an x. Let's simplify. 10x's minus 8 leaves me with 2x. I bring down my plus 30. 8 minus 8 is 0, and I have that 48 left. Now I can undo the plus 30 with minus 30 on both sides. Bring down my 2x. Those add to be 0. 48 minus 30 is 18. And I can solve this equation by dividing by 2 on both sides. And I am left with that x equals 9. This was a perfect multi-step variable on both sides. I've given some questions to us on the left-hand side. How many solutions did this problem have? It just had one. The only number that makes this equation true is 9. That is why it's just one solution. And the solution is the number 9. The number 9 is the one number that makes this true. It is the only solution. Let's do another example. This example, I actually want you to pause and try on your own using the one that we just did. Distribute and give it a go. Distribute the negative 3, and we would have gotten negative 24 minus 9h equals 5h plus 4. Notice it's minus 9h because negative 3 times positive 3 is negative 9. Now I'm ready to undo, just like we did up here, my variables from right to left. So I'm going to divide my equation in half. When I look at my variable on the right, it's a positive 5h. I want to undo that. That's the opposite of positive is negative. And I line that up with my h's. So let's bring down our negative 24. We haven't done anything with that yet. Now I have negative 9 minus 5. That's negative 14. H equals 5 minus 5 is 0. Positive 4 is the only thing left on the left. Now I can start to use opposite operations to solve my equation. I always work with my addition or subtraction first. So I look at this negative 24 and I want to undo it. The opposite of negative is positive, so I do that to both sides. Bring down my minus 14h, don't forget that negative. And 4 plus 24 is 28. Now I can divide by negative 14 on both sides because the opposite of this multiplication is division. And I'm left with h equals a negative 2. This is another equation that if we were asked how many solutions does it have, it only has one. I'm writing that on my left-hand side. If we want to know what is the solution is negative 2. Negative 2 is the only number that works to make this equation true. We have some special cases where there's not always just one solution, and we're going to see that example now. Let's distribute on both sides. 2 times y is 2y. 2 times negative 6 is negative 12 equals 3 times y is 3y. 3 times negative 4 is negative 12. And then we have this minus y. We are not ready to do any type of opposite operation on both sides until we simplify. So let's look at both sides of our equation. 2y minus 12. That's as simple as it can go, so I'm going to bring it down. 2y minus 12. But what about 3y minus 12 minus y? Look, we've got a 3y minus y. So what is 3 y's take away 1y? That's 2y. And we bring down that minus 12. Now look right here. What do you notice about both sides of the equation? Both sides are the same. That means something special is happening. But let's follow our directions of solving, and let's undo the variable on the right. So that's a positive 2y. Let's subtract 2y from both sides. And let's see what happens. 2y minus 2y is 0. We have negative 12 left on the left-hand side equals. Well, then we have 2y minus 2y. That's also 0. So we also just have negative 12. Let's read that out loud. Does negative 12 equal negative 12? Yes, yes it does. Those are the same. That is a true statement. I'm not telling you any lies. Negative 12 is equal to negative 12. So when you end up with something special like this, that means if we're actually thinking about how many solutions that we have infinite solutions. Because that was a true statement. And that means that any number makes this equation true. So the solution is all the real numbers. All of them can work. We have infinitely many solutions, and the solutions are all of the numbers in our real number system. It doesn't matter what number we substitute in for y. If we substitute it in, the equation would be true. We have another special case, and let's see it. Let's distribute this. 2 times 4 is 8x. 2 times negative 4 is minus 8. Let's bring down our 8x minus 4. I can see that there's no simplifying that needs to be done, so I'm ready to do my opposite operations. And I start and I do the opposite of the right-hand side. And that was a note we took earlier. I undo negative 8x on both sides. They both add to be 0. So I end up with negative 4 is equal to negative 8. Is negative 4 equal exactly the same as negative 8? No, that is not true. That's not a true statement. It is not true. So that means nothing is a solution. How many solutions do we have? None. What is the solution? No solution. There is not one. If you end up with a statement that is false, negative 4 does not equal negative 8, then you have no solution. All right, last example. We're actually going to go back to example 4 and we're going to practice writing an equation. This example tells us we have our friend Cameron and he buys his music. He pays 95 cents a song with his current music service. So he pays 95 cents with his current. Cameron's friend tells him of another service. So this is like Spotify and Apple Music if you still bought songs. Cameron's friend tells him of another service that you have to pay $15 to join, but you only get charged 80 cents a song. We're going to mark out this last part because we don't want to know what number of songs is like one more than the other. I just want to know, when are they equal? When would they cost the same? So let's think. When would his current service equal the new one? Let's figure out how many songs for the current to equal the new. And I've given you a pro tip over here. Usually if you see the word per, that means you're doing something per an amount. Like in this example, you buy a song for 85 cents or whatever per song. That means for every song, you're paying that amount. So if you were buying 5 songs, you'd pay 95 cents 5 times. If you were buying 10 songs, you'd pay 95 cents 10 times, which means you are multiplying. Per typically means multiplication. So we're going to set up an equation to represent his current one versus his new one. His current plan is 95 cents per song. We don't know how many songs, so that's what we use our variable as, X. But there is no joining fee. It cost him $0 to sign up. Let's compare that to the new plan. It is 80 cents per song. Let me make that a little bit clearer. But it does cost $15 to join. We want to know when those are equal. Pay attention that the amount per song is what has our variable next to it, because that's what we do multiple times. The flat rate fee of $15 versus $0 is what you pay that one time up front. It doesn't happen multiple times, so we don't signify it with a variable. Let's get ready to solve. I'm going to write this as an equation now of just 0.95x. I'm going to get rid of that plus 0 if it's okay. Equals 0.80x plus 15. We're going to follow the directions of doing the opposite operation to our variables from the right to the left. So the opposite of 0.08 is negative 0.80x minus 0.80x. That leaves me with 0.15x equals 15. I can undo this operation by dividing by 0.15. And if I use my calculator, 15 divided by 0.15 is 100. So it is at 100 songs that these plans would be equal and they would cost the same. So then Cameron would have to figure out which one's cheaper. Like if it's 99 songs, he might do the first plan, but if he does like over 100 songs, he might do the second. Rewind and watch as needed.